E = mc². This is perhaps the most famous equation in all of physics, discovered by Albert Einstein. It represents one of the most profound insights in modern science, the relationship between mass and energy. This simple yet powerful equation transformed our understanding of the universe and laid the foundation for countless technological advances. At its core, this equation tells us something remarkable. Mass and energy are interchangeable. They are not separate, independent things. Instead, they are two different forms of the same fundamental entity. Just as ice and water are different forms of the same substance, mass and energy can transform from one form to the other. This was a revolutionary idea when Einstein proposed it, completely changing how physicists understood the nature of reality. Let's break down what each part of the equation means. E stands for energy, measured in joules. This is the total energy contained in an object. M represents mass, measured in kilograms. This is the amount of matter in an object. And c² is the speed of light multiplied by itself. The speed of light is approximately 299,792,458 meters per second. When you square this enormous number, you get an incredibly large value. The speed of light squared equals approximately 9 times 10 to the power of 16 meters squared per second squared. This is a monumentally large number. What this means is that even a tiny amount of mass contains an absolutely enormous amount of energy. The conversion factor between mass and energy is huge, which is why we don't notice mass converting to energy in everyday life. But when it does happen, the energy released is staggering. Let's look at a concrete example to understand the scale we're talking about. If we could convert just 1 kilogram of mass completely into energy, we would get 9 times 10 to the power of 16 joules. To put this in perspective, that's approximately 25 billion kilowatt-hours of energy. This is more energy than a typical power plant generates in several years, from just 1 kilogram of matter. This demonstrates the incredible energy density locked inside ordinary matter. This equation isn't just theoretical. It explains real phenomena we observe and use. Nuclear power plants work because of mass-energy equivalence. In nuclear fission, a small amount of mass is converted into energy, producing heat that generates electricity. Stars, including our sun, shine because of this principle too. In stellar fusion, hydrogen nuclei combine to form helium, and the tiny difference in mass is released as the light and heat that sustains life on Earth. There are 3 fundamental insights from this equation. First, mass can be converted into energy. This happens in nuclear reactions and particle collisions. Second, energy can be converted into mass. Particle accelerators routinely create new particles by converting pure energy into matter. And third, the conversion factor between them is c², the speed of light multiplied by itself. This conversion factor determines exactly how much energy you get from a given amount of mass, and vice versa. E = mc² transformed our understanding of space, time, and the universe. It showed that mass and energy are fundamentally connected, not separate entities. This insight was crucial for developing nuclear physics, understanding how stars work, and explaining the evolution of the universe itself. Einstein's equation remains one of the cornerstones of modern physics, continuing to guide research and discovery more than a century after it was first proposed.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.